Okay, well, welcome in everybody. Thank you for coming to our Fall 2025 Distinguished Speaker Series. Tonight's presenter is Geetha Rajasekaran. She is a computer scientist with an extensive expertise in data science, AI, and enterprise automation. She's a proud alumna of Johns Hopkins University and is a current lecturer at the Whiting School of Engineering for Professionals program. She holds a PhD in information technology with a research focus on data analytics and AI. And her work centers on uncovering insights from data, advancing responsible AI, and applying emerging technologies to address impactful real-world challenges. Her talk tonight is titled Generative AI, Understanding the Foundations, Opportunities, and Future Directions. This is a talk that Geetha gave very recently at our annual Connect to Campus event, and we heard from a lot of students that they wish they could have attended, so we asked her if she'd be willing to come back and give it again in a remote setting for everybody, and she agreed. So we're very, very happy and thankful to have her come give this presentation tonight. And I'll turn it over to you, Geetha. Thank you so much.
Thank you so much, Jo. Hi, everyone. I'm Geetha Rajasekaran. I hope you are all having a wonderful, lovely day today so far. So as we are celebrating Veterans Day today, I just wanted to take a moment for the veterans here to appreciate your service. Thank you for your service and the sacrifice. Thank you. So again, I'm a lecturer at Johns Hopkins University, Whiting School of Engineering, Engineering for Professionals. Today, I'm going to take you all to the wonderful world of generative AI, and not only just the generative AI. Before jumping into the AI, there are a lot of things that you have to understand. Where we are now, it's all from different phases and different stages of AI. And we met so many challenges. And now we have, with all the infrastructure and platforms, framework, everything is available. That is the reason AI evolves very fast. And just every day it grows and fascinating for us, right? So when the movie Wall-E was released in 2008, actually a very creative, curious robot that's what just doing amazing things that human beings does, right? I think many of you have watched this movie. So at that time, it was like a kind of, it's going to happen or not. It's just a futuristic. But now we are currently in the AI era. AI is not at all a science fiction anymore. Generative AI generates all kinds of documents, movies, images, audio, video files, everything, every day. It's a lot of things going on. And Hollywood is threatened because generative AI just generates all beautiful, lovely actors and actresses, right? So it's just fascinating. And one side it is like little scary. So we have to make sure we are just getting in there properly and use the AI responsibly. So I'm going to walk you through every single step where we are and give the future directions. So when it comes to generative AI, the first thing you all get to know is, prompt. ChatGPT, Claude, and Gemini, all this kind of AI chatbots, many of you using it. So you all familiar with the prompt. So I'm sure many of you got up with very interesting prompt first time. Like kind of when you type in the first time, wow, this is AI tool. I want to use it and test it out and see what it is coming out. Kind of, I'm sure you all should have had that experience. Typing in the prompt and see what it is you are getting it, how it works, or am I getting the answer really, or what it is, like kind of. So one simple thing, one thing from my experience. So when OpenAI released generative AI in ChatGPT in kind of late 2023, November 2023, I guess, or the early 2024, when ChatGPT was available and very getting popular. At that point, I was using the deep learning and I was very aware about ChatGPT and using it and everything. So my son, who was like 9 or 10 years old at that time, he was just the first day, I think, he was trying to explore ChatGPT and typing in some prompt and trying to check something. Out of his curiosity, he was calling me like, oh, mama, come on, come on. So I was like, what is he using? I wanted to ensure whether he is using the ChatGPT properly. He has to use it what he can do or what he should not do, kind of. So I was running and just sitting with him and see what he was talking or what he was showing, just to appreciate and encourage him in a proper way to use AI tools. So he was showing like, this is my science question and I got the answer very clearly. So I was just making fun of him like, so you don't need me anymore. You can get the answers using the chat GPT, right? You like it? And he said, I like it. Isn't that cool? So I said like, oh, I love it. So amazing, right? And then he started typing the next prompt in ChatGPT and saying like, oh, my mom loves you. What do you say? And the reply from ChatGPT was, oh, that's very nice of her. I do not have the feelings like human being. That is the one very, very important thing, right? That is what we are in AI. We train the models. We train them to understand what is happy, what is sad, all the emotions, anger, and everything. We are simulating everything, train them to understand. But what is that real feeling? It's not possible with the AI system. Everything else, even though it generates all kinds of text, document, images, all this kind of, but not the real feeling. That's the one difference that we are in the current AI era. But all these things started from the very basic fundamental text handling, which is NLP, natural language processing. It is a subject area, actually, that enables the machines to understand the human language, what they are saying, what it is to reply to them, what is the response to give it to the human being, to interact with the level of the human being. That is where we started using and approaching to get, wow, I can generate the summarization, I can generate the text, I can do the topic modeling, I can do the classification. All these things popped up. So from the NLP, on the right hand side, you can see that AI is a big picture and machine learning is a subset of AI. Deep learning is a subset of machine learning. Gen AI is a subset of deep learning. If you notice the NLP includes all approaches from machine learning, deep learning, Gen AI, everything is there. That is why we are able to generate all structured data, unstructured data, whatever the responses, accuracy, predict this and that, everything is possible. All these are possible started from one basic step, which is actually many of you may have experienced when you are developing and coding something. It's normal when you read a line, if you happen to use in your use case, like, oh, how many words in the line, kind of some basic code. Okay, so what would you do usually? Like find the space and split the words and put it in the dictionary or Python list and things like that. That's a logic, right? That is where the bag of words, bow, it is called a bow. So it's originated from there. So the line or the words from the unstructured text data is split into check, like all the words, unique words, and put it in a bag, which may be a dictionary or the list. So it's a bag of words. What is the purpose of it? You can understand like how many words within the document, within the same document, or how many words are possible within different type of documents. Understand the document types, right? Classifying the documents, it's very helpful because the bow is very helpful to understand the significant words, right? There comes the next method, which is the term frequency and the inverse term frequency. So it gives away like how many times, what is the frequency of the words? So that is the term frequency. But when it comes to the line or the topic or the sentence, whenever you are reading it, there are chances that there are not important words like the, ye, be, is, was, I, me, you, all these kind of words. That comes frequently, right? So in order to reduce the weightage of those words, that is the inverse document frequency, to cut off those stopping words, those are called stopping words. That is the TF-IDF. It is called a TF-IDF, term frequency, at the same time reducing the weight of other stopping words. This BO and TF-IDF, they create, the words are converted into the numbers, numerical ways to represent the words, right? So for example, if I say like, I like NLP, I want to learn deep learning. So it is all converted into 5, 3, or 8, 2, 1, 1, 2, 2, all the numerical forms. So it is very easy to process it by the system. So when you consider this way, oh, it is very efficient. It is very easy. Yes, of course. These are very interesting methods and approaches still in use. This BO and TF-IDF are very useful currently in information retrieval and search engine. Actually, TF-IDF vectors are the base, core base for search relevant scoring models. Mini scoring based on ranking all the documents, retrieve the document, rank it, and just send it back to the user or the queries. Those are all based on the TF-IDF, that is information retrieval. It makes information very fast. So, and another thing is the feature engineering. If you are working on the statistical models and traditional machine learning models, maybe many of you may be very familiar. So these are very useful for the feature engineering. So you can combine the TF-IDF vectors with the feature engineering, numerical or categorical variables, and join with them. These are all very popular actually in the random forest and XGBoost, those machine learning, very efficient, fast machine learning algorithms. Those go with those machine learning algorithms. But even though they are very efficient, but nowadays we are all looking for the contextual embeddings, for rich, meaningful document and very huge document, long range context, huge, everything, right? So these are all very just basic approaches. It's not satisfying what our expectation is. Getting this, considering the social media site, the tweets and all, every day, the data, how much data is populating from everywhere. So the BO and the TF-IDF traditional machine learning techniques are very useful, but at the statistical model level, like the logistic regression, it is very useful for some basic predictive modeling and sentiment analysis. So these logistic regression kind of traditional machine learning models can be implemented in the social media. So when the data populates, it can generate what is that, the sentiment, good, bad, or positive, negative, things like that. And another machine learning models, very popular, and lot of machine learning models are available. Just I'm listed here where the chances of using BO and TF-IDF. When it comes to Naive is the first one where the email providers, they use it for the spam filters. Even now they are still using it. There are many email providers still stick with the Naive models. And the decision tree model. Decision tree is currently in use. If you check the chatbot, when you type in the chatbots, right, when you are asking questions, so the chatbot replies, right? So the chatbots are very helpful using the decision tree models to make the decision based on the customer intent to the different flows. If the student is asking about admission, then take the correct flow. And then if the students are asking about graduation related, then taking the corresponding flow, the decision, which flow to take the user or the customer to. It's all based by decision tree. Actually, decision tree is not only in the chatbot, it's in many places where you can think of like different routes to take, different flow to consider. So that kind of traditional machine learning models, but these are all for the structured data. It is like a very columns, like in the Excel sheet, you are very familiar with the Excel sheet, and then column names, you can read it, and that kind of very text classification, topic modeling, these are all very efficient. When it comes to latent Trichet allocation, which is LDA model, which is unsupervised, meaning it doesn't need any labeled data set. It doesn't need any labeled to let it know like, hey, this is called a yes, this is called a no. If it is like this, it is happy. If it is like this, it is sad. No, not at all. LDA just get unstructured data set just like that and use the clustering technique and put that very clearly. It understand all the pattern within the data, huge, massive data set by using the clustering technique without any labeled data set. So these machine learning techniques, the rule-based, supervised and unsupervised models are the very basic foundation for the next one, which is deep learning. So when the machine learning models are still in use, combined with the statistical models and statistical criteria and rules that can be implemented, deep learning focus on the feature engineering part. Because in the machine learning part, it is all like you have to do some kind of method and algorithms to extract the features within the data that you have. When it comes to the deep learning, the first one is it takes care of everything. You don't need to do the feature engineering. It automatically get the data. Okay, these are the features. This is describing the user authentication. This is expecting this and that. All these kind of context, everything by itself. So you can see this, the input, hidden layer and output. Actually, this is started from the neural network. Neural network was inspired by the neurons in human brain. So the input takes the input, whether it could be an image of dog, cat, and all those textual input or whatever it is, input. Hidden layer, I will talk about that. And output is just giving the output, whatever it is, either prediction or classification or bucketing everything, every details into different buckets and things like that, categorizing, things like that. The hidden layer is the main part. It does the real computation, intense logic to understand because it receives the input, right? So the hidden layer is the one processing computational logic, transforming, translating, converting, all these kind of techniques and methods to do with the input because it has to generate the output. So it does all kinds of weighted transformations and non-linear activation, meaning you can adjust the weight hyperparameters and include more layers, reduce the layers, controlling the epochs, everything within the hidden layer. You can control everything to improve the accuracy, optimizing the output is done within the hidden layer. So hidden layer takes care of everything in order to improve the accuracy within the output. So when the neural network came up with all this kind of parameters and weightage, how to add, control it, it brings down into the CNN, convolutional neural network. Convolutional neural network is only for images actually. So in that, this neural network concept, which is input, hidden layer and output, concept is for understanding the images. So when the images are sent as an input into the hidden layer, it understands what are the pattern in the image, shape, size, edge, borders, this and that, every single features within the given image. That is why in the medical field, in the health industries, it is on CT scan, MRI scan images. These are all very helpful to understand. This CNN is very helpful to understand any abnormal tissues and this and that, everything. It is very useful since it extracts features by itself. And second one is recurrent neural network. Here comes the text data. Recurrent neural network is called as RNN. RNN just read the unstructured data just like that and split into the words, tokenizing, split into words, everything. And then try to understand the relationship between the words. It is trying to understand what is that it exactly says, right? So it is processing the words within unstructured text data. It also maintains a hidden state because it is a neural network. So anywhere the hidden layer is there. So it maintains a hidden state in order to have the information about previously processed text. So when it processing the text, it maintains the state of what is already processed. So it is very easy to understand the relationship between the words and the complete contextual meaning when it processes the text. and the encoder, decoder, sequential to sequential models, but there are many different models still. Just a few of them I listed here. There are so whole bunch of it, very fascinating algorithms. You can tweak a lot, adjust a lot in order to produce very, very good, accurate result. Okay, so one is encoder, decoder. It is a two-part framework. That is encoding and decoding, you see that. So encoder is taking the input and give the contextual representation. And decoder part is just to take the contextual representation and generate the output. That's all. So it is one layer is doing one part and another layer is doing another part. So it is very easy, right? When it is converting into the contextual representation, that is a very important logic to understand what is that for, what is that text is for. Things like that, it's very easy to understand. So CNN, RNN, encoder, decoder, and all other deep learning techniques are all available, but still they are having only limited capacity for the semantic meaning, semantic relationship. That is very important, right? what is that the text says, what exactly the image says, but all these techniques are having the limited capability to just predict and say something when it comes to complex tasks. Nowadays, we are handling massive data set and very integrated systems. These kind of techniques are like little kind of making the complex task very complex, since it is not getting the semantic meaning of the text or the data that is feeding to the neural network or the input data. So that is evolved into that, especially encoder decoder is the one evolved into transformer models. Transformer model is the first basic one for nowadays current GPT models. Okay, so the transformer started from the encoder decoder. You can see that on the right hand side. It is the encoding part and the decoding part is separate and it can be controlled. So the transformer architecture was introduced in 2017 by Vaswani et al. The self-attention, that is, this paper is a really good one. Attention is all you need. There's a first paper. It is talking about self-attention. So here you see that encoding and decoding part. What is the purpose of the self-attention? Encoding, decoding, it does that very good. Then what is the purpose of self-attention? Self-attention is to look all the words within the input sequence to understand the data pattern. So actually, it means how much every word should attend to every other word in the sequence. The weighted combination of all the words for every other word within the sequence or within the line that is reading. So, which is very important to get the contextual representation, right? When it is reading, what is that weightage from other words to understand the surrounding words in order to get the clear meaning of the word it processes. That plays a very important role. It's adding with encoder, decoder. So that is where the very important breakthroughs by the transformer models. And not only the self-attention, it also has a positional encoding, meaning when the process, when the model processes the text, it has to understand not only the context, sometimes it has to understand the order, how it is coming up, the line. When you are reading the book, chapter 1 is chapter 1, chapter 2, chapter 3, right? The first line, second line. The order is very important to understand the complete story, right? So it also maintains that positional encoding when it processes the input sequence and apply the self-attention mechanism as well. And once it is done, it applies a feed forward. Feed forward network, what does it does is, it just does all kinds of transformation and mix all the features of the word that is passing the self-attention after the self-attention method and just take all the features of the words and forward in the neural network. And that is a very important thing that is in the NLP. It makes really a breakthrough. It is just like that. Because it can be processed very good when the transformer models understand the contextual relationship, and it is processed very well with the parallel processing, and we are able to successfully achieve all kinds of NLP tasks, meaning summarization, classification, categorization, this and that. So this transformer model, the best one, the transformer model is BERT model. Till now, it is very good, very efficient. You have to use that for many use cases. It can be considered for many use cases, actually. So bidirectional encoder representations. The BERT models are smart retriever. Retriever in the sense just getting very easily what you want. You want this? Okay, here you go, like that, smart retrievers. But it is encoder only. Encoder only means it takes the input and send it to the contextual representation. But when it get the output as a contextual representation, meaning it is all matching ones, matching with what you are sending as an input, whether it's a prompt or query or whatever it is, it's matching content is returned from the BERT model, can be returned from the BERT model. What it does is, it just look into the both. When it is processing the line, it look up the previous word and next word in order to understand what is the meaning of the word. Like every word it process, check the previous one and next one to process it. So to understand the contextual understanding, that is why it is very efficient. But sometimes it is like very well pre-tuned, very well pre-trained, very well pre-trained. It can be fine-tuned very well. If the BERT model is going to be used for Q&A, if it is going to be used for medical document summarization, things like that, it can be fine-tuned very well. But a little bit of thing is, it is computationally intense, actually. So sometimes it needs GPU to process it. You can take a look at that in Hugging Face, actually. BERT models are all listed in Hugging Face. The base model itself is 110 million parameters. But honestly, it is really very efficient for the classification. Okay, but sometimes it is necessary to use the GPU. You cannot process it in CPU. So, but it is very efficient. So that brings into generative pre-trained transformer, which is GPT, which is a hot topic nowadays. So it is an intelligent generator. It is decoder only. Can you imagine? BERT models are encoder only, and GPT models are decoder and generator. It can generate. But the best interesting part is, actually GPT models, when it takes the whole input line, it generates one token at a time. Only one token at a time. Not like that. But can you imagine, you enter the prompt and you got boom, you got the output, right? You got the response immediate. But what's happening behind is it just generates one token, one word at a time only. It is so amazing. So these are all auto-regressive model, and you all must be familiar with the text generation, summarization, conversation, dialogues, this and that. Everything is very efficient with the GPT model. Maybe how overall GPT model works. It generates one word at a time. That is involved in giving the prompt to the output, generating the text, for example. Okay, so that is when you enter the prompt in the GPT models, okay, this prompt is converted into vector embedding, prompt or the query that is converted into vector embedding. Actually, once you're done entering the prompt, it is getting into the tokenizer. Tokenizer takes care of the word or whatever the prompt you enter it and just break it down into the words or tokens. Tokens means the unit of text. So it can be a word or subword and everything. So it is just breaking down the given prompt into the words or subwords or token. So each word can have the token ID. because machines don't understand the alphabets and characters, right? So it's very easy in the number format, and especially vectors, very easy to process. So the words are broken down into the tokens, the tokenization process, and the tokenizer generates ID for the word to identify what is the word ID for this word. What's the ID for this word? Kind of mapped. IDs are mapped with the words. And the GPT models look into the embedding. Embedding means, which is a huge, humongous matrix, embedding matrix, which is a vector table of all the vectors. That is the GPT models, which is pre-trained, which learned from around the world. Everything it learned, it's in the huge vector space. So it is going to look into the words, the token ID from the prompt, and just check the vector space. What are the closest one, closest one, map that in the vector space. If you are very familiar, cosine similarity and vector methods are many different approaches to find what are the closest distance. So it takes that word that is you prompted and take it and token IDs and map with already learned words sitting in there in the table and compare what are the closest word for the given. That is so fascinating, right? And not only that, it just applied the self-attention, meaning what is that it exactly saying? Is that correct? The word is correct to this one? How much weight these words are given for the given word? All this self-attention mechanism. Okay, in the self-attention mechanism, GPT does another important thing is it is causal self-attention. It is called causal self-attention, meaning it doesn't worry about other future words, big words in the future coming up. It just care about only one word comes next. That's all. That is called a causal self-attention. I don't want to see that. I don't want to see all the words that is coming up. No. I'm just focusing on only one. That's masked actually. That is the causal self-attention. It doesn't worry about whatever the future. I'm going to take the previous words it processed and send only one word at a time. But you get the result very fast. So that is, and then the final step is after finding everything, self-attention, find out everything in the content and everything is ready. And then give the auto regression. Just generate one token at a time. So if you start in the prompt, once upon a time, there lived a girl in the forest. It's a prompt. It's just read that, split into tokens. Words, map with the vector space, embedding, compare the words, and automatically generates the girl lived very happily, blah, 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 blah. All the story. Right, generates one token at a time from whatever it learned by comparing the query. So let's see the simple scenario, the BERT and the GPT model. For example, a researcher wanted to know what is the impact of the climate change in agriculture. So the researcher needs to review all kinds of 200 journals, articles to understand what is that. Is it possible 200 articles to review and she has to submit? No, that's not easy, right? So here comes, it's very easy. The BERT model and GPT model are going to be helpful. Retriever and generator. Awesome, right? So the researcher can enter the prompt and the BERT model, if says the researcher query is passed into the BERT model. BERT model is a very good retriever. So the BERT model convert the user query into the embedding. The query embedding, it converted into the vector and embedded. All the documents, articles, the related journals, everything is in the document embedding already. Okay, so what it does is the BERT model takes the query embedding with the document embedding, apply the semantic similarity, cosine similarity, actually, what is the closest one, everything, check, and retrieve all the articles. Whatever is matching closest and order it, rank it, top 10 articles like that, and give it back. output from the BERT model can be passed into the GPT model. Okay, GPT is a very good generator. What it does is just take it, okay, these are all the information I need, and take it and convert into tokenization, match with that, and then combine, understand the context, everything very clearly, and then put it in a very easy, human readable, simple format for the researcher to understand. So that is the way we are enhancing the learning and just simplify the research. Easy and supporting, right? It's all available very easily. Okay. But there are some nuances in there. When GPT handles all this kind of take the information and put it out, it put it out some fake information as well. That is really from my experience. I used the same way for my GPT for my literature review. So one time when I was just checking with the chat GPT, one research article, okay, can you provide the summary? Okay, I got the summary. Second article, third article, I think it is almost 4 articles. I was able to get the summary. And maybe the next one, when I feed it, totally different content I received. Actually, summary was, you don't believe it, it's totally different. I was terribly shocked. Like, no, that is so fake. It is not what it is said in the article. It's total chaos. It is hallucinating. If you're not at all focusing on your result and not focusing on what you exactly want, you're going to be in a big trouble for sure. Okay. So that is what it is. It is fake information. Just it is making up. So it creates on its own. So it is very important when you are prompting the GPT models, it has to be mentioned what it can do, what it should not do very clearly, the prompt. So in order to make it avoid creating, even you have to mention it in the prompt, like do not create or make up things by yourself, like that. You have to mention it, that kind of scenarios. So I experienced by feeding the text document. This author, Rob Lofter, used the images actually. It is really hard to find images, but he mentioned very clearly like how you can find out whether that image that is generated is a fake or it is by AI. Very clearly you can get that. So when the text document, when you test with the text document, it is very easy to understand. Actually, when you are just working on all these kind of things with the GPT, at one point, you will be able to understand, it looks like it's from AI. Just you can understand it very clearly. You can see the pattern even in the text document, text summary. If you see that, it's very clear sometimes that is generated by AI, somewhere AI tool. It is. So this article is very clear about images. It's so, something so different, very cool. Like this author mentioned the image, the skin color just near the forehead, it's different in the hand. So that's all possible. How comes it is? The screwing up, the models are all Gen AI models, they screw up the skin color and then repeating the pattern. You can see if it is Gen AI tool generated image, then you can understand some kind of pattern. If you start comparing the images, it's going to be very clear like it is by AI, like that. Even the text within the book image, it's all going to be different. And some kind of natural scenery, it is going to be repeated in some other document. You can see that, oh, I saw that image in another place. Here it's also. So that kind of repeating patterns. And then the fur. The hair is like very soft and spongy. That hair is repeated within a human being hair, right? So it's so interesting article. You can take a look at that, how it is. You can understand the repeating patterns and textures in the images especially. So in order to make that AI models to focus on what is given as a sources, in order to avoid them to just roam around everywhere in the internet and get the content and fake the information, in order to enable them to focus, hey, there is what the sources, just to only use the sources that is provided and give me the result, like that. there comes the Retrieval-Augmented Generation. That is RAG. RAG means it is like it can be the databases, it can be the documents at wiki pages, intranet pages. If it is in the organizational policy manuals or intranet websites, all the documents for the organization, so all can be stored in the document embedding. That is a vector database. That can be a Pinecone or Facebook AI semantic search face. It's called a face. So that is all vector embedding. It can be stored there in that vector database. And so when it is augmentation is the models are going to use only that source which is in the vector embedding and then retrieve that information and check the prompt. Whatever the prompt is converted into embedding and join everything together and send it to the LLM. LLM reads and generates what is the output that is required. Understand what is the input, what's the prompt from the prompt information, and then what are the sources that is given. Use this and then use that and generate the output. You can see that on the right hand side. If the user enter the query in the chatbot, if you enter it, there's a user interface. And the documents are all converted into vector embedding on the side, knowledge sources. Maybe the databases or documents, files, whatever it is, everything is converted into embedding and stored there. So when you send the prompt, it's just getting into the source and then retrieve what all the relevant articles or relevant information for the query. And it is all sent back to the user interface. You don't see that. Actually, it is all in the back end. Then from there, it get the query embeddings, prompts is all converted into the embedding. It's combined with the prompt and send it to the LLM. Here is what the user prompt is, and these are all the sources, or these are all the information retrieved. So LLM understand what is requested, what are the information available, put it together, and not just readable format back to the user interface. That is what the RAG does, very helpful actually, because it's very important for us to get the fake information, hallucinating and wrong everywhere. So it's unacceptable. In order to avoid that, in order to mitigate that, the RAG layer was introduced, and it is very helpful. But one little bit risky thing that we are getting nowadays, it's just a huge databases. If it is a big organization, let's say at the university level, then lot of database systems, enterprise database systems, enterprise level documents, policies, it's going to be huge, right? There again, there are chances to just reduce the efficiency of LLM. So there are a lot of approaches and algorithms in order to make it efficient while using RAG layer. Next comes LangChain. LangChain and Agentic AI. LangChain is just a framework. Okay, framework or platform or infrastructure where you can just, I want to use this library. I want to just make a call to the API, and I need to make a call to the database systems, or I have to make a call to the workflow, or I have to interact with another system. All these LLMs, if you develop it, those LLMs make a call to the API, make a call to the database systems, or whatever the external tools, use the Python code to generate the code. So all this kind of tools, everything is available within the LangChain. It's a framework. And very interesting thing is all libraries, all the modules are available. For example, reading the input and parsing the output before it sends, and the embedding, actually embedding libraries for embedding is all available in the LangChain. So the developers can have many different chains. The chain, one LangChain, that can have the one LLM for one purpose, let's say one purpose, and then the output from one chain can be passed as an input to the another chain. So this LangChain is a sequential or routers or different kind of chains are all also available. Okay, so that we can, as a developers, when you are developing LLM and from end-to-end processes, then LangChain can be considered and used for LLMs to interact with different kind of different tools and the APIs. Now the Agentic AI. Agentic AI is a just amazing one, which is the high-level intelligence system. So it is where the LLMs can act autonomously, meaning it is acting on the react paradigm. That is reasoning. When you prompt it, then it understands, it's thinking like step by step. Oh, this user asked for this. I need to make a call to the API. Second step, I need to make a call to the database, like step by step. Planning and then executing, just to trigger. Second step, after reasoning, after understanding, after planning, it just executing, act to initiate the contact and get work on it and reflect. Third step is reflect. It just correct on its own by getting the output and working on it before sending it to the user. It revises itself, that is reflecting. And even it can make the decision. If the plan A is not it's not working out, then it switches to the plan B, plan C, like changing the decision making. And it is very task oriented. The user asks this, I want to get that done. So I have to make a call to the API. Here you go, LangChain is available. Make a call to the API, make it available. If the RAG layer is available, it's all integrated within the LangChain and make it as one big agent. Everything is just within a second. By sending the prompt, you can see that research assistant agent. It is also another example. It's using LangChain and the agentic approach. So users send a query and the pre-processing. When the input data is fed, it has to be cleaned. Many of you know that, and working on that, cleaning is taking a long time. Massive data set, you have to just make sure everything is perfect. LangChain has all the modules to do that. Then once it is done, it's sent into the LLM. LLM within the LangChain agent. So it is going to think about, oh, this prompt is going to have, this many steps. I have to initiate the task. So it is followed by the LangChain can make a call to all the sources, whether it is a PubMed or semantic scholar article, Google Scholar, whatever the sources are. Just LangChain, LLM thinks that is a chain of thought, COT, it is called a chain of thought reasoning. Okay, so it is just the LangChain initiate, trigger that, whatever LLM thinks, and then LangChain initiate and get everything that is need to be sent back. So it aggregate and then maybe list by year or relevance of the article with the other recommendations. Everything is generated and LLM put it together, very clean document outside to the user. So agentic AI is actually built on top of the reasoning framework. Reasoning is very important, right? It's all like step-by-step thinking, goal-oriented, and just like that, switch the plans, making decision. It's all very possible. So it opens up great opportunities everywhere using RAG, LangChain, and agents are nowadays very popular. So it's all boost productivity. Everywhere, education, research, every industry, they are trying to use AI and generative AI, especially to do the analysis, coding part of it, how to generate the text properly, even visuals, very clear visuals of data interpreted very properly using LLM. So it's all very helpful for productivity. And as you know that just before, it's workflow integration, seamless integration of API. If you are developing huge enterprise-side systems, you must be very familiar because to make one API call, it takes forever to make it work and everything. And then another call, another type of code you have to develop to interact with the database, like one by one. But here, using LangChain and all this LLM, all the systems are all integrated together very easily. The flow is very good, easy. And the human AI collaboration, we cannot avoid that. So AI generating the code, and it is very important that you should not copy and use it actually, because sometimes it is fake. We human beings, we are all very efficient and smarter than AI system. So we have to collaborate, learn it and update our knowledge by using and collaborating in a useful way. So opportunities are there. But when there are opportunities, there are challenges and risk are also there, right? So on the technical perspective, accuracy and hallucination, which is very, very important because you cannot say the author John as a doe, right? So it's faking information. So there are a lot of steps, lot of models, evaluation techniques. These are all developed and in order to mitigate the hallucination and improve accuracy. When it comes to data privacy and security, AI systems are all based on how quality the data is. It's all depends on data. How big and how quality, everything matters. So the data storage is supposed to be secured. And processing, encryption, decryption, all these methods should be applied while processing. And there are chances for the prompt injection. Okay, so wrong prompt can be passed through that. Oh no, that's scary, right? Medical information, if the people in an organization type the wrong social security number or this and that. So it's very important to train the people, all this kind of technology related. And on the other end, ethical, one more thing, that is bias and fairness. Bias and fairness can be avoided. I mean, everywhere there are steps taken to test it with a wide variety of diverse data set and a kind of auditing framework. It's all incorporated to see, make sure it is not biasing. All these kind of steps are all included and enforced. Ethical and legal side of it, copyright and the intelligence protection. That is the big thingy, IP for the user. That is really a scary part, actually. One recent experience, very recently I heard, one of my friends who is very good writer, he released many books. One of his recent book is a science fiction. So he recently reported that his book was used for training the model, AI model, without his consent. Can you, he is just going to take legal action. That's what I heard. So can you imagine? So it should be avoided. The ownership should be identified and properly credited, which is very, very important. Or when they are training the model, the publicly available data that's available, or the licensed data, or consent from the owner, right? So that kind of steps need to be addressed that way properly. I hope it's all happening and in progress. Misinformation and deepfakes. Yeah, there are a lot of things, lot of different algorithms to verify the models and things like that. The different ways are just evolving every day to make it and fix these kind of things. Okay, so governance and compliance gaps. That's an important thing. Organizations are taking steps in order to just comply with the policies and regulatory, in developing the regulatory frameworks, and legally it is all okay. That kind of steps are all taken, is all in progress to make sure it is ethically and legally okay and fine using the models. Okay, and we all know that it is at every organization, we are all facing little trouble, work disruptions, and over reliance on the AI. That is not okay. That is also can be, it is needed, because we have to believe that human beings are smarter and we have to collaborate very well with the AI systems. And the transparency and accountability. Transparency is whenever we are handling the data, and especially for the AI system, which is just to work very well based on the data. So it is like, it is very important to make sure that it's all handled transparently, and whatever it is needs to be followed at organizational level or the kind of group level, different entities based kind of accountability. These are all the things that happen at the organizational level. Accountability is if the model is going to generate incorrect result, okay, which is very important at the outside. If it is in the public or outside, incorrect information, fake information, false information, who is legally and ethically responsible? That is a kind of thing when the AI models are developed. So the AI, responsible AI, is all like organizations are working on developing responsible AI framework. Is deviating at what time, the kind of documentation and making it very clear and aware at organizational level. All these are steps that are all in progress in every area in order to make the AI systems very good way to be used efficiently in a good way. And as a user, we have to use it responsibly. We have to understand the responsible. Okay, we have to take the responsibility of its use. In the future direction, it's all accuracy and reliability, which is our very important goal. And like I said, it's all different steps and algorithms to improve the efficiency, accuracy, and reliability. And privacy preserving, which is also another highly important, since the prompting and converting vector embedding, which we are not going to focus on the vector embedding. We are focusing on the input, how it can be. So it has to be controlled there. Then the input and what is generated in the output, we have to put the guardrails there in both ends in order to make it accurate and protect the information. And strong governance and standards everywhere, ethical guidelines and auditing framework is all enforced to ensure every step of the AI processes are handled properly. And another interesting point in the milestone 2 is domain-specific model, because it just give into the different buckets, right? It's narrowed down if it is towards education related models. So it is very easy to control and manage and implement what are the necessary criteria for that education. For education domain, what are the necessary criteria that the model should comply with if it is only healthcare focused? So that's all coming in. So if it is like that, it is very easy to control based on the domain specific details, which is very important. Okay, milestone 3 is like agentic AI. That is on the top of reasoning models. So it is like it's just booming every day actually. It plans, act, and then it's just they are doing with the reinforcement learning. It is also another approach which is using the reward model in order to boost the agent to make the correct decision. So agents within the reinforcement learning framework as well. So that kind of all the agentic AI with all the integrated systems are all coming up. It's so fascinating to see that it's all just like that coming up. And human AI co-creation and a collaboration, which is really important. We have to understand our responsibility and take the accountability for the things. And at the same time, we have to make sure we know what we are feeding in the model, what is coming out in the model, what we are sharing outside, everything, the data. Data has to be governed first before feeding into the AI model. That can be very good actually. And then evaluation, after processing it, evaluation is very important. And human intervention is nowadays, it's all in everywhere to make sure it's all correct and human level. It's all, but agentic AI is like a kind of autonomous. It makes decisions just like that. So it's very important to enforce the collaboration in a good way. And multimodality, it is also happening. It is progressing. Like when the people are talking and generating the corresponding images and generating the text all at the same time, handling everything, right? Converting something and translating something all at the same time. It is all coming actually. It is almost a progress. It's in great progress actually, multimodality. So these are all in progressing stages, and some of them here in the milestones that's mentioned, it's all like a kind of at a good level, good percentage, we can say that. Some of them are very good, interesting, but we have to be very careful when integrating and making the things work. So whatever we are doing and focusing on, it is all towards green model design. It's all sustainability. It's all very important when it comes to the AI models and methods and techniques, AI systems. Okay. So I think you all have a wonderful, you all enjoyed this talk very well. If you have any questions, I am very happy to answer your questions.
Thank you so much. That was a great talk. And as Geetha said, if you have any questions, you're welcome to raise your hand or throw them in the chat for her. You can also email her separately if you want. If you have longer questions, you don't want to take people's time. You're also welcome to, leave. It is late, so you don't have to stay too long. But yeah, that was great. Thank you so much.
Thank you so much, Joe.
Of course.
Thank you, everyone.
Yes, thank
You can
you.
reach out to me anytime. Thank you.